Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to start exercise 1.4, and in this exercise we will discuss about radical equations. So let's define the radical equation. An equation involving expression under the radical sign is called a radical equation. For example, in this question, this given equation is a radical equation. Why? Because the right hand side you can see there is a radical sign. This expression is under the radical sign. So this equation is a radical equation. So you can see another this question too. Here the left hand side, this expression is under radical sign. So this is radical equation. Question 3 is same as it is. So here you can see that this expression is under radical sign, this expression is under radical sign, and this expression is under radical sign. So these are the, so this is also a radical equation. Here this quadratic expression is under the radical signs. So the equations involving the radical signs, you can say that equations are the radical equations. So how we can solve the radical equations? So there are different types of radical equations. So first we are going to start the first type of a radical equation. In this type, the left or right side of the equation with radical sign. Here this right hand side is with radical sign, and the left side is without radical sign. To remove, we have to remove the radical sign. So how we can remove the radical sign? Just we have to take square on both sides. So let's start the to solve question number 1. Question number 1, 2x plus 5 is equal to square root of 7x plus 16. So solution, now we have to remove this radical sign. So how we can remove this radical sign? Just we have to take square. So taking square on both sides. So after taking square, we have this type of expression. So here a plus b whole square, we can use the formula a plus b whole square. By using that formula, this is 2x square plus 5 square plus 2, 2x and 5. And this square would cancel out with this square. So we left with 7x plus 16. So here we can write 2x square as 4x square. So this is 5 square is 25, and 2 2s are 4, 5 4s are 20x. Here is, and right hand side is 7x plus 16. Now we have to shift this value, this expression, to the left hand side of the equation, and we have 4x square, this is 20x, and here is 7x. When we shift this into left hand side, we have minus 7x. So 20x minus 7x is 25, and here is 16. When we shift this into the left side of the equation, we have minus 16. This will be equal to 0. So 20x minus 7x, we have 13x, and 25 minus 16, which is 9. So we have this quadratic equation. So this is the standard form of the quadratic equation, and we can use factorization to solve this. So when we multiply this 4 9 times 36, and we can take the two factors, 14x and 9x. 4x and 9x. 9 4s are 36, and we add these two factors, we have 13x. So 13x can be written as 4x plus 13x. So now from these two terms we can take 4x as a common. So we left with x plus 1. So in these two terms we can take 9 as a common. So we have x plus 1. So here x plus 1 is a common. So we left with 4x plus 9 is equal to 0. So either x plus 1 is equal to 0 or 4x plus 9 is equal to 0. So if this expression is equal to 0, it means x is equal to minus 1. If 4x plus 9 is equal to 0, then 4x is equal to minus 9 and x is equal to minus 9 by 4. Now we have uh, two solution of these equation. X is equal to minus 1 and x is equal to minus 9 by 4. Since this type of equation contains the extraneous roots, so the roots which not satisfy the equation, given equation, is known as a extraneous root. So that we have to check whether the given uh, solution satisfy the given equation. If this solution is not satisfying that solution, then that solution will be a extraneous solution. So let's checking, put x is equal to minus 1 this given equation. So when we put x is equal to 1, we have this type of expression. And when we simplify this expression, so we have 3 is equal to 3, which is true. So it means x is equal to minus 1 is the solution of this radical equation. Now the second solution is x is equal to minus 9 by 4, and we have to put this in the given equation. So after putting, we have this type of equation. So just we have to multiply here, and here just we have to multiply, and just we have to take LCM. Here we have to take LCM, and here is 4 LCM, and here is also 4 LCM. And after simplification, and left hand side we have 2 by 4, and right hand side we have square root of 1 by 4. So which is equal to, so this can be written as 1 by 2, and this square root of 1 by 4 is also 1 by 2, so which is true. So it means x is equal to minus 9 by 4 is also the solution of this radical equation. So the solution set is minus 1 comma minus 9 by 4. Question 2. So the radical equation of first type. So now we have to remove this radical sign. To remove this radical sign, we have to take square on both sides. So just taking square on both sides, we have this expression. So here 3x minus 1 whole square. So we'll use the formula a minus b whole square, which is a square plus b square minus 2ab. So when we take square, this square cancel with this square root, so we left with x plus 3, and in right hand side we can write as 3x square plus 1 square minus 2 into 3x into 1. So now 3x can be written as 9x square. This one can be written 1 square is 1, and after multiplication this term is minus 6x. So now we have to shift these values into left hand side. So when we these shift in the right hand side, we have 9x square, and just we have to write in the descending order. So 9x square minus 6x, and this is minus x. So here is plus 1, and when we shift this into right hand side, we have minus 3 is equal to 0. So we can write this as 9x square minus 7x and 1 minus 3, which is minus 2, is equal to 0. So this is again a quadratic equation in standard form. So now we have to factorize this. Since we can factorize this term, so we will not use the quadratic formula. If the equation we are not able to factorize that equation, so we'll use the quadratic formula. So here we use the factorization. So 9 2s are 18, and these are minus so this will be minus 18x square, and we have to find two factors. When we multiply, we have minus 19x square, and we when we add those terms, we will have minus 7x. So these are two factors, minus 9x plus 2x. About factorization, we have discussed in detail in ninth. So if you have any problem, you can revisit your factorization method. So after factorization, we can write minus 7x is minus 7x plus 2x minus 2 is equal to 0. So here in these two terms, we can take common 9x, so we left with x minus 1 here. In these two terms we can take 2 as a common, so we have x minus 1. So now we can take x minus 1 as a common, and we left with 9x plus 2. So here must be equal to 0, just write this is equal to 0. So x minus 1 is equal to 0, or 9x plus 2 is equal to 0. If x minus 1 is equal to 0, it means x is equal to 1. If 9x plus 2 is equal to 0, it means 9x is equal to minus 2. So x is equal to minus 9 by 2. Now we have the solution set as x is equal to 1 and or x is equal to minus 2 by 9. Now we have to check either these solutions satisfy this equation or not. So just put x is equal to 1 in the given equation. So after putting these, this is 1 plus 3, 3 into x minus 1. So this is 4, and left hand side we have 2. So after simplification, we have 2 is equal to 2, which is true. So it means x is equal to minus 1 is the solution of this radical equation. Now we have to check either the x is equal to minus 2 by 9 is the solution of this radical equation. So now just we have to put x is equal to minus 9 by 2 in the given equation. So after putting, we have this type of expression. Now we can take 9 as a LCM. So 9 3s are 27. So we have minus 2 plus 27 divided by 2 whole square. So here 3 so here 3 2s are 6, minus 6 by 9 minus 1. So we take LCM here. After simplification, we can write this as 25 by 9, and in right hand side we have minus 15 by 9. So here when we take square root, we have 5 by 3, and this is equal to minus 15 by 2, so which is not true. So 5 by 3 is not equal to minus 5 by 3. So we can say that x is equal to minus 2 by 9 is an extraneous root. So the solution set is x is equal to is 1. Extraneous root is that root which is from which we find by solving the radical equation. But when we put that root into the equation, and that root will not satisfy the given radical equation, so we'll say that that root is an extraneous root. So this is also the first type of radical equation. Now just we have to shift this minus x to the right hand side of the equation. Now we have to solve this type of this equation. So how we can solve? Just we have to take square on both sides. So after taking square, and here we have to use a plus b whole square. So after simplification, we have this equation: x square plus 5x minus 84. So just we have to factorize, and we can factorize is at this is minus 84x square, and 12 sevens are 84, and when we add these two terms we have plus 5x. So in these two terms we can take x as a common, so x plus 12 minus 7, here we can take x, so minus 7 as a common, so we left with x plus 12 is equal to 0. Now we can take x plus 2 as a common, so we left with x minus 7 is equal to 0. So x plus 12 is equal to 0, or x minus 7 is equal to 0. Here it means x is equal to minus 10. Here means x is equal to here x is equal to minus 12, and here we have x is equal to 7. Now we have to check that these solutions satisfy or not the radical equation. So let's put x is equal to minus 12 in given equation 1. So when we put x is equal to minus 12, we have this type of expression. So after simplification, we have 20 is equal to 4. So we know that 20 is not equal to 4. So minus 2 is so minus 12 is an extraneous root. Why? Because this root is not satisfying the given equation. Now we put x is equal to 7 in the given equation. So when we put this equation in this solution in this radical equation, we have this type of expression, and 7 3 is 21, this is 100, this is minus 7 is equal to 4. We have 121, and square root of 121 is 11 minus 7 is equal to 4. So 4 is equal to 4, which is true. So the solution set is 7. So now we have another type of a radical equation. In this type, all the expressions with the radical sign. So these are the three different terms with radical signs. So again, we have to take square on both sides to remove the radical signs. So just we have to take a square plus b square plus 2ab. When we take square this, we left with x plus 60. So this cancel out with this one, we have x plus 5. This cancel out with this square root, we have x plus 21, and here these values is same as it is. So this is x plus 15. You can write this in a same radical sign, and then we have to multiply these values. So x plus x is 2x, and 5 plus 21, this is 26, plus now we have to multiply these equations of radical sign. Just you have to add some more step. You have to take one more step and just write this in a single radical sign. So when we multiply this with this one, we have x square, and when we multiply x with 21, we have 21x. When we multiply this 5 with this x, we have 5x, and when we multiply this 5 with 21, we have 105, and this is equal to x plus 60. Now we shift these two terms to the right hand side of the equation, and just we have to simplify the expression which is under the radical sign. So after simplification, we can write this as x square plus 21 plus 5, 26, and this is 105, and right hand side we have x plus 60 minus 2x minus 26. So when we simplify the right hand side expression, we have minus x plus 34. Again, you can see that we have a radical sign. So there is the only way to remove this radical sign is that we have to take square on both sides. So taking square on both sides of the above equation, we have this type of expression. Here we can, when we take square, and this radical sign will disappear, and square of 2 is 4. And here we use the formula a minus b whole square. So we'll write 34 square plus x square minus 234 into x. So here we multiply 4 with this expression within the brackets. So here we can write this 34 square is 1156 x square, and after multiplication this expression is minus, this term is minus 68x. So now we have to shift these terms into the left hand side of the equation, and after simplification we have 3x square plus plus 132 plus 130 sorry 3x square plus 172x is equal minus 736 is equal to 0. So here we'll use the quadratic formula to solve this equation. So here this is value of a is 3, and b is 172, and the value of c is minus 736. So we know that the quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac over 2a. So just we have to replace the values of a, b, and c. After replacing and after simplification, we have x is equal to minus 172 plus minus 196 divided by 6. So first we write with negative sign, and secondly we prefer the positive sign. We use the positive sign. So simplification, after simplification we have x is equal to minus 184 divided by 3, or x is equal to 4. 4. So these are two solutions of this radical equation. X is equal to minus 184 divided by 3, or X is equal to 4. So now we have to check either these solutions satisfy the given radical equation or not. So checking, put X is equal to minus 4 in equation 1. So when we put this X is equal to 4 in the given equation 1, we have 4 plus 5 square root of 4 plus 21, and this is equal to 4 plus 64. So this is 9, this is square root of 25, and this is 64. So square root of 9 is 3, and square root of 25 is 5, and square root of 64 is 8. So 3 plus 5 is equal to 8, and this is also 8. So 8 is equal to 8, so which is true. So we can say that X is equal to 4 is the solution of this radical equation. Again, check, put X is equal to minus 184 divided by 3 in equation 1, and after putting the equation and after simplification, we have this type of equation. So this type of condition, 24 iota divided by square root of 3 is equal to 2 iota divided by square root of 3, so which is not true. So X is equal to minus 184 by 3 is the extraneous solution. So solution of this radical equation is X is equal to minus 4, or 4 is the solution of this equation. Again, question number 6. This is the second type of the radical equation. Again, we have to solve this equation in same way. Just taking a square on both sides. This is a square b square plus 2ab is equal to this square. When we take square, the right hand side, this square root cancel out with this one square. So we left with x plus 4, x plus 6. So now x plus 1. So here we must have the radical sign. Question number 6. This is a radical equation of type 2. So we'll solve this equation same as we have solved question number 5. So taking square on both sides of equation 1. So left hand side we can use formula a plus b whole square, and in right hand side this square cancel the square root sign. So we left with x plus 4, and in left hand side we have square root of x plus 1 whole square plus square root of x minus 2 whole square, and plus 2 square root of x plus 1 into square root of x minus 2 is equal to x plus 6. So this square root cancel out with this square, and this square root cancel out with this, and these two radical forms can be written in a same radical. So these two expression can be written in same radical expression. So here we have x plus 1, here we have x minus 2 plus 2 within square root x plus 1 into x minus 1 is equal to x minus 6. So now x plus 1, 2x minus 1 plus 1 minus 1 plus 2, just we have to multiply this with this one, x into x, x square, x into minus 2, minus 2x, 1 into x, x, and 1 into minus 2, we have minus 2 is equal to x plus 2. Now we have to shift these two terms to the right hand side of the equation, and here we have 2 square root of x square minus 2x plus 1x. So we have minus x minus 2 and x plus 6, and when we shift these two terms to the right hand side of the equation, obviously we have to change the sign of each expression, each term. So we have x plus 6 minus 2x plus 1. So we can simplify this as here 6 plus 1 is 7, and minus 2x plus x, we have minus x. Again we have a radical sign, and the only way is that we have to square these terms. So taking square on both sides, so this term square and right hand side square. So when we take square of 2, we have 4, and this square will cancel out with this, and here we have to use the formula a square minus a minus b whole square, that is equal to a square minus b square minus 2ab. So x square 7 square plus x square minus 2, 7 into x. So here we have to multiply each term of term which is within the bracket with 4, and 7 square is 49, and here is minus 14x. So now we have to shift these terms to the left hand side of the equation, and you have to remember that you have to change the sign of each term when you shift these term into the left hand side of equation. So we can write this as 4x square minus 4x. Here is this is plus 4x minus 8 minus 49 is equal to 0. So after simplification, this is equal to 3x square plus 10x minus 57 is equal to 0. So here is so we can factorize this quadratic equation. So after factorization, we have this type of expression: 3x square plus 19x minus 9x minus 57 is equal to 0. So here we can take x as a common. So when we take x common, we have 3x plus 19 within the bracket, and here we can take minus 3 as a common, and we have 3x plus 19 within the bracket. So here is 3x plus 19, and here is 3x plus 19. We can take common 3x plus 19, so we left with x minus 3 is equal to 0. So 3x plus 19 is equal to 0, or x minus 3 is equal to 0. It means 3x is equal to minus 19, or x is equal to 3. So here 3x is equal to minus 19, so x is equal to minus 19 by 3. So we have two solutions: x is equal to 3 and x is equal to minus 19 by 3. So now we have to check that these solutions satisfying this equation or not. So first, putting x is equal to minus 3 in equation 1. After putting these x is equal to 3 in equation 1, we have 3 plus 1 in square root, square root 3 minus 2, square root of 3 plus 6. So we have 4, here is 1 and 9. 4 is 2 plus 1, and square root of 9 is 3. So 3 is equal to 3, which is true. So x is equal to 3 is the solution of this radical equation. Now putting x is equal to minus 19 by 3 in equation 1, just we have to put here, then you have to take the LCM, which is 3, and here in right hand side, this is also LCM is 3. So after simplification, so here is minus 1, this is minus 1, so it means this minus 1 can be written as iota square, and so this will be 16 iota square divided by 3. So this can be written as 4 iota divided by square root of 3. Here is, this is 25, this is minus 1 is iota square, so 25 iota square can be written as 5 iota, and this is square root of 3. Here is iota square minus 1 can be written as iota square, so iota square can be written as 1 iota with square root of 3. So here when we add these two terms, we have 9 iota by square root of 3, and is equal to 1 iota divided by 3, or iota divided by square root of 3. So you can say that this is not true. So x is equal to minus 19 by 3 is the extraneous solution, or extraneous root, you can say that. So the solution set is x is 3. Question number 8, square root of 4a plus x minus square root of a minus x is equal to square root of a. To remove the square root, signs or radical signs, we have to take square on both sides. So taking square on both sides, we have this type of expression. Here we use the formula a minus b whole square, a square plus b square minus 2ab, and when we take square of this, when we take square of the square root of a, we have a. So a square b square minus 2ab. So we write these two expression with a single radical sign. 4a plus a, 5a minus square root of, when we multiply these, this is same way how we have multiplied in the previous question. So after multiplication we have this type of expression. So here we have to shift uh, here this plus cancel out with this minus x. So we left with 4a plus a 5. So we have to shift this 5a to the right hand side of the equation, and this expression after simplification can be written as. So here we can divide both sides with minus 2. So after division we have this expression. Now we have again a radical sign, so just again taking square on both sides. So this square root cancel out with this square, and 2a whole square is equal to 4a square. So now we have to shift this 4a square to the right hand side of the equation. So this 4a square, this is plus 4a square, and this is minus 4a square. So this cancel out with this one, and we left with 3x plus x square. So here we can take x as a common, so 3a plus x is equal to 0. So either x is equal to 0 or 3a plus x is equal to 0. It means here if 3a plus x is equal to 0, it means x is equal to minus 3a. Now we have to check either these solutions satisfy the given equation or not. First put x is equal to 0 in this equation. So when we put x is equal to 0, we have this type of expression, and after simplification we have square root of a is equal to square root of a, so which is true. So it means x is equal to 0 is the solution of the given radical equation. Now put x is equal to minus 3, x is equal to minus 3 in equation, given equation. So when we put this, so 4a minus 3a square root of a, this is 4a, 4, so here is a, and minus this is 4a. So 4a can be written as 2 square root of a. So here is this is a error. This is, you can say that this is a typing error. So this must be, this 2 is outside the radical sign. So when we add these terms, we have minus square root of a is equal to plus square root of a, which is not true. So x is equal to minus 3 is not a solution of this equation. So we can say that this is a extraneous root. So solution set is 0. Question number 9, and this is a third type of a radical equation. You can say that here the quadratic expression is in the radical sign. In this type of equation, you can see that here is x square plus x, and here is again you can say that x square plus x. So we have to put this expression to y. So let x square plus x is equal to y. So we have to put y, value of x square plus x is equal to y in equation 1. So we have square root of y plus 1 minus square root of y minus 1 is equal to 1. So just shifting this term to the right hand side of the equation. This is for simplification. So we have so we can simplify easily. So that's why I am shifting minus square root of y minus 1 to the right hand side of the equation. Now taking square on both sides, when we take the square, this square root cancel out with square, and we have y plus 1, and here 1 square is 1, and when we take the square of y, minus 1. So square root cancel out with square, so we left with y minus 1. And here is, this is a, this is b, so you can say that we are using formula a plus b whole square. So we must have 2ab. So 2ab term can be written as 2 into 1 is 2, and this is the term square root of y minus 1. Now we can, this plus cancel out with this plus 1 cancel out with this minus 1. So we have y plus 1 is equal to y plus 2 square root of y minus 1. So now we shift this y to the left hand side of the equation. So this y cancel out with this y. So here is positive, this is negative. So these two terms cancel with each other. So we left with 1 is equal to 2 square root of y minus 1. So again, this is a radical equation. So we have to remove this radical sign. So taking again square on both sides. So 1 square is equal to this expression whole square. So this can be written as 5 into y minus 1. So when multiply these two terms with 4, we have 4y minus 4. So when we shift this 4 into the left hand side equation, we have 1 plus 4 is equal to 4y. So 5 is equal to 4y. So now just we have to put the value of y in this expression. So putting y is equal to x square plus x. So we have 5, 4 into y is equal to x square plus x. So we have to multiply this with 4x square plus 4x. So we have to shift this term to the right hand side of the equation. So 0 is equal to this, or this is equal to 0. This is the same. So now 5 fours are 20, and we have no not two terms, so that we sum the, we multiply that two terms, we have 20, but when we add these two terms, we cannot find this is equal to 4. So we use the quadratic formula to factorize these two. So here a is equal to 4, b is equal to 4, and c is equal to minus 1. The quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac over 2a. So just replacing the values of a, b, and c, we have this type of expression. So how we can solve the quadratic equation by using the quadratic formula, we have discussed in our previous exercises. So these types of the calculations you can do easily. So I am skipping the detailed explanation. So after simplification, here we can take 4 as a common. So this 4 cancel out with this 8, 4 2s are 8. So we have minus 1 plus minus square root of 6 divided by 2. So the solution set is minus 1 plus minus square root of 6 divided by 2. Question number 10. Again, this is a radical equation of type 3. Here is x square plus 3x, and in this radical sign we have x square plus 3x. So we have to replace x square plus 3x is equal to y. So let x square plus 3x is equal to y. When we put the value of this in equation 1, we have square root of y plus 8 plus square root of y plus 2 is equal to 3. So now we have to shift this term to the right hand side for simplification. So taking square on both sides, we have square root of y plus 8 whole square is equal to 3 minus square root of y plus 2 whole square. So here we have to use the formula a minus b whole square. So after writing, after expanding the formula minus b whole square, we can write this expression as given here. So here 3 square is 9. We have y plus 2 minus, here is minus 6 square root of y plus 2. So 9 plus 2, 11 plus y minus 6 square root of y plus 2. Now we have to shift 11 plus y to the right hand side of the left hand side of the equation. Obviously we have to change the sign of these terms. So after simplification, we have minus 3 is equal to 6 square root of y plus 2. So again we have to take square to remove this radical sign. So after taking square, we have here 9 is equal to 36 y plus 2. So when we multiply y with 36, we have 36y, and when we multiply this 36 with 2, we have 72. We have to shift this 72 to the left hand side of the equation. Sorry. So we have 9 minus 72 is equal to 36y. So 9 minus 72 is minus 63. So uh, 36y is equal to minus 63. Now we have to replace the value of y, which is x square plus 3x. So after replacing the value, we have 36x square plus 108x, and when we shift this minus 63 to the left hand side of the equation, we have plus 63. So now we use the quadratic formula to solve this quadratic equation. So here we have a is equal to 36, b is equal to 108, and c is equal to 63. So the quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac over 2a. After replacing the values of a, b, and c, and after simplification, we have x is equal to minus 3 plus minus square root of 2 divided by 2. So the solution set is minus 3 plus minus square root of 2 divided by 2. Question number 11. X square plus 3 plus 9 within square root plus square root of x square plus 3x plus 4 is equal to 5. Then we have to put y is equal to x square plus 3x. So when we replace the value of y in given equation, we have, we have square root of y plus 9 plus square root of y plus 4 is equal to 5. Now for simplicity, we shift this term to the right hand side of the equation, and taking square on both sides, when we take square, this cancel out with this one. In right hand side, we have to use the formula a minus b whole square, which is a square plus b square minus 2ab. So after expanding this expression by using a minus b whole square, we have this type of the equation. So this question, since this question is same as we have question number 9, 10, and so you can so simplify these terms. So after simplification, we have 2 is equal to square root of 1 y plus 4. So again taking square on both sides, to remove this radical sign. So 4 is equal to y plus 4. So this 4 cancel out with this one. So we left with y is equal to 0. So y is equal to 0. So put y is equal to 0 in equation 1. We have x square plus 3x is equal to 0. So here we can take x as a common. So we left with x plus 3. So x, this product is equal to 0. So either x is equal to 0 or x plus 3 is equal to 0. It means x is equal to minus 3. So the solution set is 0, minus 3. So this is all about the exercise 1.3, and this is the last exercise of this unit 1. So inshallah in next lecture we will start unit 2, and just you have to remember how we can factorize the quadratic equation, how we can find the solution of the quadratic equation. So Allah Hafiz.